this graph, sorry for those guys at home, I screwed up. Okay. If we go back to this graph, does this look like it's going to have a y-intercept of 0?
Yes. Yep.
Like as I take this line all the way through?
Yes.
It's going to be pretty darn close to 0 the way it's set up right now. Is everybody good so far? All right. So something very special about direct relationships is that we can kind of when it's a direct relationship, coming up with the slope of the line that creates that is actually relatively easy to do. So let's think that through a little. And that's why I have this extra set of rows here. Is what we're going to do is create a new list of numbers that is the ratios for each thing here. Now, what do you guys remember about slope? Anything you remember?
Y equals mx plus b.
Okay. And in y equals mx plus b, what is the slope?
X.
M.
Yes.
M is my slope. And if I asked you to describe in words,
Rise over run.
rise over run, does that sound familiar?
Yeah.
And if I asked you, well, what is really the rise of a function? It is the change in y. What is the run of a function?
Change in x.
Change in x. Okay. Now, are you guys with me? That the change in y over the change in x in a direct relationship would be the y, just y over x. Okay, this only applies if we have this like direct 0-0 relationship. Okay, so my y is my time. My x is the number of breaths. Is everybody good? So if I were to find the ratio for this first point, I would take the time over 1 and just get 0.75. Okay? What would it be for the second point? I would do the time, 1.83, divided by the number of breaths is 7. Or 2. And what do you get when you do 1.83 divided by 2? .915? Now, before you guys start working ahead, I'd like to show you something if that's cool. Okay. So, to do this next part, you're going to need to take out your calculators. And what I'd like you to do is put all those breaths in L1 and all the times in L2. Is everybody good? Take a second. Breaths in L1, times in L2.
How do we get there again?
Stat.
Just stat for a second.
Just stat, yep. And then edit. Mm-hmm. Is everybody good? Do we need another second to get these in? Okay. All right, now, what I'm about to show you, the intent of what I'm about to show you is when you have to do the same operation over and over and over again, you don't want to do that over and over and over again. It would be great if we could just do it all in one fell swoop. You guys know that expression, one fell swoop?
Yes.
Like all at once. Okay. So when you think about, as we're creating this list of these ratios, okay, what we're really doing is just creating a new list of numbers based 100% on the L1 and the L2, yeah? All right. So what I'd like you guys to do is go over to L3, okay? And if you look at that L3, and if you arrow up so that your cursor's not on that first line where you put in points, but rather on like that header of it. And if you just hit enter, it should just say L3 equals. Is this okay? Not L31 equals, it just says L3 equals. Is everybody there? And what I want to tell L3 to do is I want it to be all the values in L2 divided by the corresponding values in L1. Is this okay? So I can, if I hit second 2, it'll type in L2 for me. So go ahead and hit second 2. And then hit the divide by button. And then second 1 so that it says L3. So it should say L3 equals L2 divided by L1. Everybody good? And when you hit enter, it finds all of them for you. It just does all of it at once as soon as you hit enter. Everybody good? So rather than having to type each fraction over and over and over again, it does the division for you. Is this okay? We call these doing list operations. Trying to do them in the list weren't the same size. Yep. Anybody else have a question on their calculator? That's what we're trying to find is these numbers. All right, so do you guys see how this can find those ratios for us really quickly?
Yes.
All right, so 0.75, 0.915, then we've got 0.84, 0.69, 0.6, or that'll be 70, 0.68. I'm just rounding to the nearest hundredth. And for the most part, guys, does it stay relatively consistent?
Yes.
There we go. Ish. That kind of works. Okay. All right. So, you know, it'd be really good. What if we could just kind of come up with one value that represents all these ratios? Still not recording. I mean, I didn't record any of the first page, but that's okay. It'll be all right because we're going to reference back to it and I can circle back. It'll be okay. All right, so here's what makes something a direct relationship. There are two things that I care about. Something is direct if the increases / I guess technically decreases, though we're not really going to see many, are consistent. And this is a big and, 0 for x corresponds to 0 for y. So, for example, if I put no breaths in my balloon, would it go up in the air?
No, unless you threw it.
But even then, the time up in the air would be minimal, right?
Yes.
You guys see what I'm saying? Like, there's nothing propelling it. So this is a direct relationship because, one, it was going up by the same amount each time, give or take. And 0 breaths correlates to 0 time in the air. Okay, so both of those things would be necessary. Another way of saying this, guys, is that the y-intercept on the graph should equal 0. And if we go back to what I'd like us to do,
That would be dope. Could we add them all together and then divide them by 10?
so we don't even have to do that. The calculator is going to do it for us. The mean of the ratios seems as good as any to me as a good representation of this, right? All right, so to find that mean, we could go in and now type all of those numbers in L3. But I don't know about you guys. The more decimals it gets, the more irritating I'm going to get trying to find those, yeah? And the reason we did these operations is what if instead we did our one variable stats like we were doing before, okay? But now we don't want to do those one variable stats on the first list. We want to do it on the third list. Is everybody good? So go ahead and hit stat. Arrow over to calc. You're going to choose option 1 that says one variable stats. And where it says which list do you want me to do it on, we don't want to do it on L1. We want to do it on
L3.
L3. So how do I get it to do it on L3?
Second 3.
Second 3. See, you guys are on this. Guys, which one's my mean?
0.69.
So this would round to 0.70.
Yes. What do we put down as frequency list?
Nothing. You leave it completely blank. The frequency list should be completely blank.
Okay.
We all good? All right. So, in your guys' head, guys, what does that really mean? That was our average when we did time over breath, yes? Is this okay? All right, so what if I put 11 breaths in the balloon? And by me, I mean, what if Chai put 11, this is your data, Chai. What if Chai breathed into the balloon 11 times?
It might pop.
It might pop. How big was it getting? Very big. All right, are you guys with me? That if I took that 0.70 times the number of breaths, that should give me the time. Is that okay? Roughly? All right. So we were talking about slope on the previous page. We said slope is change in y over change in x. In this case, that would be the change in time over the change in breaths, right? Now, are you guys cool if I call this 0.70 out of 1? Does that make sense? So we found that ratio overall to be 0.70. If I needed to think of that in terms of refraction, because remember slope is change in y over change in x, right?
Yes.
Okay. That fraction would be at a 1. Anytime we try to change any number into a fraction, we can put it a fraction over 1. Okay? So what does this mean? Like, what's the meaning of our slope?
What does it mean?
Well,
Mean for every breath you take, the time will go up by 0.7 seconds.
for every one breath, the time in the air will increase by about. Are you cool if I said approximately 0.7 seconds? That feels a little bit better to me than just saying it will go up, because it's not a perfect relationship, right? It's an approximation. So far, what do you guys think of direct relationships?
Makes sense.
Can you think of anything else that might be directly related? As in, goes up by about the same amount each time, and has a, like 0 implies 0. Yeah.
Like height to weight on a person?
Maybe height to weight. Maybe height to weight. It's definitely a positive relationship between height and weight. I don't think it's a zero-sum game, where 0 height equals 0 weight. Like, there's no such thing as 0 height and 0 weight. Does that make sense?
Well, if you aren't any inches tall, then there's not.
But then you, like, don't exist, right?
Zero.
Like, it has to be a situation where 0 and 0 also makes sense. Yes, Walter?
Age and time?
Age is time.
No, time is because of age. Age is because of time. Age is a direct relation.
Net.
Yeah.
Your age is a time period, yes?
Yeah.
Okay, so you're not talking about two variables there.
1 year, you're 1 year.
I'm going to argue that that's not two variables. Did you have one?
Oh, I was gonna say, for every one step someone makes, like the distance that they move.
Sure, that would work, because it makes sense to have 0 steps being 0 distance, right? But, like, that's, if I'm not moving right now, that makes sense. But if I take 3 steps or 4 steps or 10 steps, sure. What else?
Gallons of water to weight. Like for each gallon of water, you have a certain amount of weight that weighs.
Yeah, that's if it's actually water, then it's perfectly straight. Sure.
Word up to time in class.
That probably has a negative relationship. No, it doesn't.
How many classes?
I would imagine you guys were bored before you walked in here. Yeah.
No. Choir was exhilarating.
Truly.
Because let's put it this way, you might want to start brainstorming some relationships that are direct.
I think I see.
Because there's going to be a project
Whoa!
next week that will be the last project of this 9 weeks, because that is over next week. It'll be a very short, small project. But you're going to need to come up with a direct relationship. Yeah. How about hours worked and money made?
That's facts.
No, please.
Time spent running, distance covered.
Times poked, annoyance gained.
Hmm?
Times poked with annoyance gained.
I would imagine that's exponential, not linear. Yeah.
Did you say distance and speed?
Our distance and speed, distance and time, distance and speed, distance and speed. Distance and speed if you're going at a consistent for this.
Cruise control.
Huh?
There's cruise control.
Cruise control.
Well, yeah, but if that's the case, the distance is changing over time, not the distance is changing over speed.
Did you say with technology?
Also exponential. It wouldn't be consistent. The jumps in technology have gotten bigger and bigger and bigger. Overall, very exponential.
But it can still go down.
With the amount, but like what measurement of technology?
Well, I mean, we can't replicate pyramids, so how great are we?
We could.
But like you're trying to take something that has like 50 variables that influence it and represent it as technology. When in reality, technology is, are you talking about the time it takes to compute something? Because that has gotten significantly smaller than when they built the pyramids, right? Like it just depends on what measurement, what metric you're using.
What do you think of the pyramids?
They're cool.